told you that sometimes law of sines gives you two answers or bad answers. Okay? We're going to talk about those situations today. We're also going to apply law of sines more to solve more triangles. So we have two scenarios. I'll give you time to copy this. Just pause for a moment and just watch just a moment. The first scenario is when angle is less than 90 degrees. The second scenario will be when the angle is greater than 90 degrees. Within this first scenario, we have two situations. Okay? We have the first one where A, the side opposite the angle, this side's opposite this angle, is less than the other side. And we just chose this side to be the one we're looking at. It could have been the other one, but it just would have been flipped over. Okay? Within this scenario, when A is less than that, we have three situations. We have one where this side is shorter than this green side, the perpendicular. We have one where it's equal to that perpendicular, and we have one where it's longer than the perpendicular. Okay? And so when it's longer, and this is hard to do because as I swing this, it changes lengths, but if I was swinging this around, it would hit here, and as I swing it around, it hit again over here. Okay? And if I swung this one around, oops, I didn't mean to erase my A. As I swing this one around, you'll see it's too short. It doesn't touch that line at all. So it won't make a triangle if it's too short. Okay? And so we have a scenario where it's too short to make a triangle, right here. We have a scenario where it's exactly long enough to make a triangle. And we have a scenario over here where it's too long and there's two possible scenarios. All right? And then if it's longer than B, then if I was to swing this around, it wouldn't end anywhere but in that one place. Okay? And so I'm going to pause now so you can finish copying this. Just to make sure you understand where these come from. B sine A. Well, if I'm looking at angle A, this side right here that was the green dotted line, I'm going to call X. That's the opposite of angle A. Is that correct? And B is the what to this triangle? The hypotenuse. Well, opposite and hypotenuse is sine. So we would say sine of A is equal to opposite over hypotenuse. And if I multiply both sides by B, I get X is equal to B sine A, which is what we have in all of these. And so we're saying if A is smaller than that side, that's why I've got the red line here drawn smaller than this altitude, the perpendicular, then it's not going to make a triangle. If the red line, the A value, is equal to that green line, then it's going to make exactly one triangle. And if it's longer than the green line, it's going to make two. Okay? What I told you the other day was, if you always use the biggest angle, if you know the biggest angle and the length of the side opposite, then it's always going to make one triangle. Okay, it's when you don't know that side, you don't know the longest side, and you're looking for that longer side, that's when we can run into some problems. Okay? So the second case, again, if A is smaller than B now, it won't make a triangle. And if A is bigger than B, it'll make exactly one triangle. So much simpler when our angle is bigger than 90 degrees. there's only two scenarios. Either the side opposite's not long enough to make a triangle, or it's going to make one triangle. So the first example, how many solutions does this have? Okay? The only significance in these letters is angle A and side A are opposite each other. Okay? So we're looking at a situation where if this is A, this is 63 degrees, this is 18, and this is 25. Okay? And so if we go back, angle's less than 90, and the side opposite A is less than B, and so it's going to be one of these three scenarios based on what B side A is. In other words, based on what this side is compared to the 18. And so sine of 63 is equal to opposite x over hypotenuse 25. And so x is equal to 25 sine 63. And so we need to know about what that number is.
22.3.
22.3. So is it longer than that?
Longer. So
And so if we go back, whoops, there I went too far. When A is longer than this side, there's two solutions. When A is equal to that side, there's one solution. When A is less than that, there are no solutions. So let's go back and see what we have again. We found this to be 20, did you say 22?
Yeah.
And that's longer than 18, isn't it? So that means then that there are no solutions. There's no triangles that will work in that solution, in that setup. There's no triangles that will work. This green dotted line is actually 22.3, and that's longer than this side, so it's really not drawn, shouldn't be drawn the way it is. Okay? So we're going to use B sine A to find this unknown to help us determine if it actually makes a triangle, if it makes two triangles, or no triangle. Okay? This is number 4 out of the book. Would somebody, you have your book open? Tell me what that question asked to make sure we're answering the right questions. If you have your book open, please read what number 4 says.
Like in the homework?
Yeah.
Determine the number of possible solutions.
Okay. How many solutions? So same thing as the last one. And so, again, if I draw this, this is 21, this is 22, this is 72.2. And so it's same as the last one we did. It's less than 90. And the opposite side is shorter than this side. So if we look for this distance here, call it x. X is going to equal 22 sine of 72.2. And so what is that? Louder, please.
20.9.
20.9. So 20.9 is shorter than 21. So therefore, there's going to be how many solutions? Yeah, it could be this one. Or this one. over here. So there's two solutions there. Okay? Oh, really? Okay. Sorry. All right. Your assignment today . 11 through 31 odds. And we're going to take our time quiz here in a minute. Our time quiz is going to be 8 minutes today. I'm going to actually time it.